This is lesson 7.6, okay, in our red textbook. Okay, today we're dealing with solids of the same type that have a proportional corresponding linear measures are called similar solids. Okay, what do we mean by that? Well, let's take a look. We're identifying similar solids. So this is a solid, which is a cylinder. This is a solid, which is a cylinder. First of all, they both are cylinders. Okay, so they have the same shape. Okay, but now we need to see if they are proportionate. It says in comparison to this one over here. Okay, all of them are cylinders. Okay, so it says which cylinder is similar to cylinder A? Is it B or is it C? Let's check to see if corresponding linear measures are proportional. Okay, so let's take a look. If we look at the height of A, which is 4, and the height of B, which is 3, then we look at the radius of A, which is 6, and the radius of B, which is 5. Then we see that they're not proportionate. So this is 4 to 3. This is 65. Another way some of you like to do it is you do 4 to 3. You would say 4 divided by 3, you get 1.33. But when you say 6 divided by 5, you get 1.2. They do not have the same amount. They're not proportionate. Okay. So then let's take a look then to C to A. All right. The height is 4. And for C is 5. Okay, so it's 4 to 5. And for the radius is 6. The radius here is 7.5. 6 to 7.5 is 4 to 5. They're proportionate. Well, you don't automatically see that. Okay, so since you don't automatically see that, because you say to yourself, it can't be simplified by the same number, then what you could do is, once again, 4 divided by 5 is 0.8, and then 6 divided by 7.5 is 0.8, okay? And then therefore you clearly can see that they are proportioned, okay? All right, so now let's move on to number 2. On example 2, it says the cones are similar, find the missing slant height L. Okay, so here you have the radius. In this case, it's 5 for cone X. So you have the 5, and then you have the radius for cone Y, which is 7. There's your 7. Okay, be sure we get those in there. Okay, then so you have the radius to radius, X over the Y, and then you have the slant to slant, X over Y. The slant to the X is 13, the slant to the Y is L. So you have 5 to 7, you have 13 to L. And so then, therefore, you can now cross multiply to solve for L, okay? And so, therefore, you have 5 times L, which is 5L, 7 times 13 is 91, and then you isolate L, and you have L is equal to 18.2, okay? So let's take a look at our 2 examples here at the bottom of the page. At the bottom of the page, it shows us here that, let's see, give me some room, little room. There we go. We're at the bottom of the page. It says cylinder D, okay, has a radius. Okay, we're referring back to the shapes up here. So we have A, B, C. Now they're speaking of D, okay? We have, straighten this up a little bit. All right, here we're dealing with linear measures, okay? Here we have our square prism, our square pyramid, our cylinder, our cone, our cylinder here, and our cylinder solids here, both of them, okay? It says the surface area of a similar solid. If 2 solids are similar, then the ratio of their surface area is equal to the square of the ratio of their corresponding linear measures. Okay, so let's see what that means. The surface area of A over the surface area of B is equal to the square of surface area A over surface area B. So let's see how that looks. The pyramids are similar. What is the surface area of the pyramid? So here, these two pyramids are similar. All right, so now the surface area S over the surface, for here, we don't know the surface area, but here we do. So the surface area S is over the surface area B, which is 600, is equal to the square of the height, 6, over the height, 10. Okay? And so therefore, we can cross multiply. Okay? And therefore, we can discover that once we cross multiply and isolate, S is equal to 216. Okay? So let's check out this procedure here with number 3 and number 4. Okay? Running out of scratch paper here. Just get me a new one. Alrighty then. It says the solids are similar to the next page. Okay? It says the volumes of similar solids. If two solids are similar, then the ratio of the volumes is equal to the cube of the ratio of the corresponding linear. So here we have volume A over volume B, and then we cube A over B, whatever the measurement is, okay? So we can do that with a surface area, it will be squared, but for a volume, it will be cube. All right, so let's take a look here at our standard practice. All right, the dimensions of a touch tank at an aquarium are double what is the volume of the new tank. All right, so you have the original volume, the new volume, the original volume, because it's volume, cube over the new dimensions. All right, so you have 200, and they show you that the volume is 200. That's the original, okay? Over the volume, you don't know what is for the new tank. And then the original, okay, they're showing you that the tank was 1 to 2. All right, so you put the 1 to 2, cube it. All right, so you have 1 over 8, 200 over V, cross multiply, and V is equal to 1600. Okay, so D would be your answer. Let's look at 5 and 6.